Have a look at adding resistance. So we've already done a little bit on this, and we've done some conceptual work on adding resistances, but we'll look at this in a more analytical way. So start off with resistors in series. So if we've got a load of resistors in series, then these will just add up sequentially. Right, so if we've got some electrons trying to go through this resistor, you can imagine it as being like a water circuit, and that resistor is like something that's restricting the flow, like pinching off the flow. And then if we go then have another resistor after that, so that's like having another restriction in the flow. These just add sequentially to the total amount of restriction to the flow we've got, this thing we call resistance. So in series they just add sequentially. Okay, when we've got resistors in parallel, it's a little bit different, a bit more complicated. So the key concept to remember here when we're thinking about how resistors add in parallel is that the voltages, the voltage supplied by the battery and the voltage drop over all these resistors is all the same. Right, so again, we can come back to our water circuit analogy. So if this is a pump that's adding some pressure to this side compared to this side, right, then there's along here we've got pipes that we assume are basically perfectly have zero resistance to the flow of water, which holds in a real circuit, because it will be almost zero resistance to the flow of water if we've got relatively big restrictions here. So there's nothing along these paths to cause a drop in pressure. There's effectively no restrictions. So if we have our pump that's adding some pressure here, then all the parts that are connected directly by these water pipes will be at the same pressure. Right, and the same on this side. Right, so this is the kind of start pressure where we're calling zero. And again, because these are all connected by pipes, these must be at the same pressure. And the same goes for an electrical circuit. Right? If this is a battery, it's adding some voltage to this side compared to this side. Right? And so everywhere connected directly by wires will be at the same voltage. And we don't get a change in voltage until we get to a resistance. So that's the key concept. This voltage and the voltage over this resistor, voltage over this resistor, and this resistor are all the same. The next key concept is that the currents, the sum of all the currents through the resistors is equal to the current supplied by the battery. Right, so we've got a battery supplying some current I0, the current comes along here, and some of it can go down there, some of it can go down there, and some of it can go down there. But all of these three currents must be equal to this current that's being supplied by the battery. So just using those two concepts, we can use our Ohm's law that we looked at last week, this V equals IR. So we can rearrange that for current. So we can say then that this current I0 is equal to this voltage of the battery divided by the total resistance of this network of resistors. So that's what we want to find. We want to find what the total resistance of all these resistors together is. Just call that R total. And that's going to be equal to this voltage divided by this resistance, so that's I1. So I1 is V1 over R1. I2, that's V2 over R2. And I3, that's V3 over R3. So that's just using Ohm's law and these two concepts that we looked at. So we're just saying this total current is equal to I1 plus I2 plus I3. And then we know that all the voltages are the same. So this V0 is equal to V1 and which is equal to V2, etc. So we can replace that with V0. And so we've got V0 over R total is equal to V0 over R1 plus V0 over R2, etc. And then if we just divide by V0 on both sides, then we get 1 over R total is equal to 1 over R1 plus 1 over R2, etc. So we just need to then take the reciprocal both sides, so that will give us R total is 1 over R1 plus 1 over R2 plus 1 over R3. So that's how we derive our equation for adding resistors in parallel. And then a slight shortcut, if we've only got 2 resistors in parallel, then we can use this product over sum rule. So we can say total resistance, just give it this sign, this double backslash, and it's just slightly less cumbersome than this equation. So you can say R1 times R2 divided by R1 plus R2. That's the equivalent of an equation like that. I'll give you the same answer.